This is my friend Jack, about to get killed by my rocket. But before you can see the rest of the video, I need you to watch exactly what went into making this.
3, 2, 1.
I can't even show you the static fire. If you want to see anything, you either need to skip or you're going to have to watch a video and learn something. Because it's time for E.O.S. Part 3. So this project took me around a whole year to plan, design, and create. I had to design this in CAD on paper, and then actually had to 3D print and trial and error with all the pieces, and it took a long time to make everything. I've been building this rocket in my shed for around a year now, and I've had to create and design and re-engineer most of the rocket. The first stage, for example, had to be re-engineered 3 times because wires and cords, everything wasn't working. So this is the top stage of the rocket, and it's, as you can see, it's attached to the bottom stage. And what this does is it has an integrated flight computer for a future video that we're going to explain how to make. You can see when it blasts apart, it pulls out the parachute. And the problem was it didn't pop out the parachute. So it's actually my bad that the rocket didn't actually take off successfully. Well, it did take off, it just didn't go as high as planned. When the rocket took off, it shot up, and then the motor mount went up inside the rocket, basically displaced inside the rocket, which caused everything to be unbalanced. And when it was going up, then it started going over to the side, and well, it crashed, as you saw in the video. For this rocket, it was supposed to go around 200 feet because we used store-bought motors. These store-bought motors aren't as powerful as the homemade motors we're going to be making in the future. But right now it's really hard to get a hold of black powder, which is needed for the construction of the homemade motors. So I bought some readily available motors that aren't as strong, but so I could get a video out to you guys so you could see how everything was working and stay engaged with the E.O.S. project in general. So I 3D printed an adapter for an E.12 Estes engine. As you can see, things didn't quite go as planned. As you can see in the video, the rocket took off. That's when the engine mount slid inside the frame because I didn't screw it in. And when that happened, it displaced the center of gravity, and that made everything unstable. So it went over and crashed, almost hitting my friend Jack. The engine actually broke off the engine mount while it hit the ground, and that caused a lot of problems. As you can see, a lot of the fins broken, most of the body is damaged and may have to be replaced in the future. So the parachute was really easy and simple to design, and I'm not going to release specific plans because it's still in the works, and it's very flexible and it doesn't need to be really specific. What I did is I took a tablecloth from the dollar store, and then I just cut it into a circle, and then I just attached strings in between 2 3D printed pucks that kind of added strength so the strings wouldn't rip through. And then I folded the entire thing up and then jammed it inside the rocket. And then all those strings are attached to one center hub that you can 3D print. There's a link in the description. And then it's attached to a long string of paracord, or you can use a shock cord, an elastic cord, and that will basically keep the rocket 2 halves from falling apart, and you won't need 2 separate parachutes. And the paracord was glued into the special 3D printed attachers that are linked in the description, and then they're screwed into the side of the airframe. It's not very specific where you put them in the airframe. Again, this is all I'm still in the works on this, so it's really flexible and you can kind of modify it. So there was a lot of damage sustained on the rocket this flight. However, the current design, it's a prototype, and it'll slowly get modified over the time that I make it. In a future video, I'll explain how to make the flight computer. I actually had the flight computer already made and on board the top stage of the rocket. Thankfully, when it crashed, there was no damage done. And part of the reason this flight may not have gone as well is because they implemented that flight computer maybe a little bit earlier than it should have, and I ended up moving batteries and cameras and components around inside the rocket, so that way the center of gravity was in the right spot. So the launch pad, actually, that launch tower, isn't actually needed. It's completely decorative. Maybe in the future I'm going to implement more design that maybe makes it have a purpose, but for now it's just decorative, and the only thing that actually keeps the rocket from going crazy is the rod. And so there are these small launch lugs attached to the rocket, and then those go on a rod, and that rod goes stick into the base. If you 3D printed the base, you'll notice there's a little hole. That's where that rod goes. You can get this rod at Home Depot, really any hardware store you can find usually has a 3mm rod that should fit perfectly in the base. You can also drill it out if it's not the right diameter. But the big thing is you just want a metal rod so that rocket will be able to build up speed, and the air will go around the fins and keep it going straight while it's still on the pad and gaining speed. So at 5 a.m. we woke up, got ready, and headed out to the launch site 30 minutes away. And we got there just in time. The weather was just holding out. It wasn't windy. It was perfect. It was sunrise. The lighting conditions were good. So we thought we were go ahead for launch. But I forgot to mention we had a static fire, so that way we could test how the rocket would actually act in air and make sure there were no red flags.
3, 2, 1. 3, 2, 1. Three, two, one.
It's the night before the launch, and we're getting things ready for next morning. Up early, ready for the launch. Car's packed and ready to go. We arrived at the launch site and we're getting ready. Well, that's it for this video. Thank you guys for watching and supporting. Big thanks to all the people who donated money. We actually got over what we needed for the project. We got $150. Thank you so much to all my supporters, and see you in the next video. Stay tuned for E.O.S. Part 4.